Hello everyone. I am Mr. Prashant Patil from Red Shikshan Sanstha's Arts, Science and Commerce College, Mokhada, District Palghar. So today we are going to study paper 1 from TYBSc semester 5, that is multivariable calculus 2. So in this paper we have three units, that is first unit is multiple integral, second is line integral, and third is surface integral. So in this lecture we are going to study multiple integrals. So multiple integrals means here we are going to study about double and triple integrals. So uh, we'll first of all have some introduction part. So let us have introductory part, that is in this chapter we are going to study the definite integral, not definite integral, but so we are going to consider first of all the introductory part. So in this chapter, we are going to extend our idea of definite integral to double and triple integrals of the function of two or more variable, or you can say two or three variables. So we have seen in the previous year that is in 12th standard, first year and second year, we have seen the integrals with only one variable, that is definite integral. So here we are going to extend this idea to double and triple integrals. So these ideas are going to use to compute volumes and masses of some more general regions, not the only our like a square region, or you can say circular region, or but it is we are going to study about more general regions. Okay, so we'll see that polar coordinates are useful in computing double integrals over some type of region. We have seen this one in the previous year. So similarly, we will going to introduce two coordinate system in three-dimensional spaces that will simplify computing of triple integrals over certain commonly occurring regions. That is, so first is the cylindrical coordinate system, and second one is the spherical coordinate system. So before going for the directly to the double integral or triple integral, first of all let us review the definite integral. तो हम एक काम करते हैं, डबल इंटीग्रल और ट्रिपल इंटीग्रल के पहले हम डेफिनेट इंटीग्रल, दैट इज ऑन सिंगल, वी कैन से सिंगल इंटीग्रल जिसे हम कहते हैं, तो पहले वो हम थोड़ा रिव्यू कर लेते हैं. सो लेट अस रिकॉल द बेसिक फैक्ट्स कंसर्निंग डेफिनेट इंटीग्रल ऑफ द फंक्शन ऑफ सिंगल वेरिएबल. ठीक है, तो देखते हैं. सो आई एम गोइंग टू कंसिडर वन फंक्शन विच इज डिफाइंड ऑन ए बी. So what do we do in this regard, that first of all, for the Riemann integral of the function f, we need the partition of the set AB. So what do we do, that we start by dividing the interval AB into n subintervals. That is, we are going to start dividing the intervals AB into n subintervals. That is, we call it as xi minus 1 comma xi in general, of equal width, that is width is given by delta x, which is given by b minus a divided by n. So this is the width of the each subinterval. So what do we do here is, we just choose any arbitrary points, or you can say sample points xi star, call it as xi star in these subintervals. जो भी xi minus 1 comma xi जो सब इंटरवल है, उसमें से उसमें से हमें एक पॉइंट चूज करना है एक्साई स्टार इन ईच सब इंटरवल, आई वुड से. सो सपोज हमने लिया लिया सब इंटरवल x0, तो उसमें x0 स्टार कंसिडर करें, या फिर x1 स्टार ऐसे कंसिडर करेंगे. बाद में x2 x3 लिया सपोज, सो उसमें से x3 स्टार ऐसे sample point collect करना है. Okay, so like that. Okay, we are going to consider one sample points, or you can say arbitrary points, in those subintervals. So we are going to form the Riemann sum. ऐसे points तो ऐसे पॉइंट्स कंसिडर करके हमें क्या करना है, तो हमें रीमान सम फॉर्म करना है. सो वी आर गोइंग टू कंसिडर रीमान सम, दैट इज summation I is from 1 to n f of xi star and into delta x. So this is similar as upper sum and lower sum. In upper sum you can say that f of xi star की जगह इधर होता है capital Mi, that is supreme of the function in the sub interval, right? And in the lower sum, lower Riemann sum, we are having over here replacing this mi star, that is small mi. So we that is infime of the function in the subinterval. So it is similar as lower sum and upper sum. So this is summation I is from 1 to n f of x star into delta x. Delta x the width of the subinterval. So here then we can take this limit of such sums. So we are going to consider limit of sums. ऐसे हमें limit of sum लेना है ऐसे ये Riemann sum के, so that we are getting so we are going to form the Riemann sum as summation I is from 1 to n f of xi star into delta x. So then we take the limit of such sum. ऐसे sum के हमें limit लेना है, limit as n tends to infinity to obtain the definite integral of f from a to b. So जो definite integral जो है वो हमें कैसे मिलेगा? So limit of these sums, limit of these Riemann sums, as you can see that a to b f of x dx, ये जो definite integral है वो हमें ऐसे मिलेगा, limit of sum, limit n tends to infinity as summation I from 1 to n f of x star into delta x. So definite integral actually क्या होता है? So it is limit of sum of you can say Riemann sum, limit of Riemann sum. Okay, so some special cases, that is say f of x greater than 0, मतलब function positive है suppose, non negative है suppose. So in that case the Riemann sum can be interpreted as the sum of the areas of approximating rectangle. So I will show you by using diagram. See here, you can see that this is the diagram of function, you can say positive function A. This is the function red colored. Okay, and defined on this AB, you can see this A comma B. Okay, this is the partition we have done, and you can see that it is suppose say x0 x1 x2 and so on. So these are the xi stars I what I said in the previous slide. जो भी मैंने कहा है ये देखिए, x1 स्टार लिया है x0 x1 की जगह. Okay, x1 x2 में in this sub interval we have considered x2 star over here, suppose this is a, and then x3 star and so on. So this is in general xi minus minus 1 में we have considered xi star as a arbitrary point and so on. So we have seen that we have drawn a rectangular region, right? So this function is approximated by rectangles. You can see that in this way. So next is we can get double integral, that is definite integral, single integral, I would say, uh, represent the area under the curve of y equal to f of x from a to b. We know already, we have seen in the 12th standard that definite integral means what? The area under the curve. So how is that? So it is in this way we can specify this. Okay, so now let us have a double integral over the rectangle. So now in this section we are going to learn about double integrals and how to use them and to find the volumes. So see here, we have just now we have seen that the area problem, it leads to the definition of definite integral. एरिया प्रॉब्लम हमने जस्ट नाउ सॉल्व किया, तो उधर से हमें मिला कि वो डेफिनेट इंटीग्रल जो है वो दिस दैट इज नथिंग बट द लिमिट ऑफ सम। तो उससे हमें डेफिनेट इंटीग्रल का डेफिनेशन मिला। सो इन दिस सिमिलर वे, लाइक वाज वी नाउ सीक टू फाइंड द वॉल्यूम ऑफ सॉलिड। सो वॉल्यूम ऑफ सॉलिड हमें फाइंड करना है, तो हमें डेफिनेशन मिल जाएगा डबल इंटीग्रल का। सो इन दिस प्रोसेस ऑफ फाइंडिंग वॉल्यूम ऑफ सॉलिड, वी आर गोइंग टू अराइव at the definition of double integral. So let us have, okay, so before going for that double integrals over the rectangle directly, we need some terms. We need some terms, and we need some preliminaries. So we are going to study those terms, and then we will arrive to the definition of double integrals. So first of all, we need a domain. So that domain, from now we are going to study, that is rectangle. So first of all, what is the rectangle? So definition of rectangle is, let R is equal to all those, this is the, so the rectangle R is nothing but it is the set of all those tuples, two tuples. Two tuples belongs to, of course, R2, such that A less than or equal to X less than or equal to B, C less than or equal to Y less than or equal to D. That is, X lies between A and B and Y lies between C and D. And you just take the tuples, that is two tuple. So this is the rectangular region, that is actually A comma B cross C comma D. So where x equal to A and x equal to B and y equal to C and y equal to D. So let's have a look at that diagram. So let us have a diagram for this rectangle. So this is x-axis and this is a y-axis. So x equal to A and x equal to B. So this is the, you can say this one. So A less than or equal to x and x less than or equal to B. Okay, so here we are going to draw the x equal to A and x equal to B over here, that is the bound of x, and y equal to C and y equal to D. Yeah, this is like C less than equal to y less than equal to D, that is y equal to C and y equal to D. These are the bound of y, you can say. So as we have drawn this one, you can see that this is a rectangular region. So now, so this is a rectangular region that we are going to study, and we are going to apply, or you can say we are going to define the function, most of the function on rectangle. So let us have now, we have seen that we have defined a rectangle. Now we are going to study about double integral. So we need some terms, that first term is the rectangle, then we are going to partition the set, as we have seen in the definite integral, definition of definite integral. We have partitioned the set, and then we have found, you can say infimum and supremum, or you can say, you can consider Riemann sum, and so on. So similar way, in the similar way, we are going to do the same in the finding the double integrals over the rectangle. So we have seen this rectangle as R is equal to this. Okay, now we are going to partition the set, this a comma B cross C comma D. So let us have the definition of partition of this set, or you can say partition of the rectangle. So see here, first of all, let us consider P1 as the partition of AB. How is it? So P1 is equal to A equal to x0, A को आप मान लीजिए x0, बाद में x1 x2 and so on xn, और xn को आप मान लीजिए b. Okay, so this set is a partition of AB. Okay, and P2 similar, in the similar way. Okay, so it is the set of all those points, that is C is equal to y0, y1, y2 and so on, and P2 is the partition of CD, which is